straight away, and we're going to get into paper 2. And we're going to start off with the stats section. Okay, so up on the board, we've got a question. We've got some a data set. And it says an ice cream vendor recorded his daily sales for a period of time. The number of ice creams that he sold each day is given in the table below. And then there's a bunch of questions. So I'm going to leave you to it for about 3 minutes to work on this question. And then at about 5 past, we'll sort of check in with each other and see how you are doing, and then be ready with your questions. Okay, so until 5 past, work on this question, and then we'll check in, see how everyone's doing. That's no problem, Andre. Okay, so our time is up. Let's have a look. Has anyone figured out what the mode of the data is yet? Put it in the chat if you know what the mode is. Swabali says it's 15. I definitely agree. Mode is the most. So yeah, we've got 15, 15, and 15. And no other number appears the same number of times. So that's 15. Good stuff. Now determine the median of the data set. What is the median? Did anyone manage to figure that out? Sibabali says 24. Hartis also says 24. Yes, that's right. Okay, so the median is the middle number, and they've actually made it nice and easy for us to do that. That's why it's only 1 mark probably. But if we count 1, 2, 3, 4, 5, 6, 7, 8, 9 data values, and then this is the 10th one, and then another 1, 2, 3, 4, 5, 6, 7, 8, 9. So that one is dead in the middle. So that's 24. And then what about the interquartile range? So for the interquartile range, we need to first do the upper quartile and the lower quartile, and then subtract those two numbers. So Sibabali already has an answer and says it's 12. I would like everyone else to also give this one a go. It is a very standard question that I would like everyone to get right in their paper 2 if they are still writing this week. So first, let's do, maybe someone can tell me what the lower quartile is. Which number is the lower quartile? Again, the way the numbers are set up, they've done it quite easily. So remember, the lower quartile is from the median that way, and then the upper quartile is from the median this way. And we don't include the median when we do that, because the median's already like a point. That's good. Well done, Sibabali. That's right. That's 13 is the lower quartile. So if I look at my data values, 1, 2, 3, 4, 5, 6, 7, 8, 9 data values, the middle one is going to be 13. And then what is the upper quartile? You can tell us what the upper quartile is. Now, Sibabali also, that's 38. Let me use my green for that. Well done, Harties. And Mondre, good stuff. So the interquartile range then will be the difference between those two numbers. So that is 38. So 38 minus 13 is going to be 25. So that's nice, easy marks. 3 marks, 1 for the upper quartile, 1 for the lower quartile, and 1 for your final answer. Okay, and then on the scaled line diagram in the answer book, so obviously you will also have an answer book when you do your paper 2. So this paper had an answer book. It's the November 2019 paper, in case you were wondering. November 2019, we did the paper 1 last week, and this week we are carrying on with the paper 2. So there will be an answer book for this. And the for the box and whisker diagram, we're going to need the 5-number summary. So can anyone tell me what the 5-number summary is going to be? We already have 3 of them, so the rest is pretty easy. Jan Saka says Q1, so low quartile 13. And which other numbers? The min, that's right. So the minimum value is 5. And then the lower quartile, or Q1, is 13. Then Saku's listed them very nicely. Q2 is the median, and that's 24. And then the min, we've got already, that's 5. And the max we've got is 24. And then Q3 is 30. Not 24, 55, 38 and 55. Okay, awesome. And then to draw your box and whisker plot, even if you don't get an answer book, you do need to draw a scaled line so that your box and whisker plot is evenly spread out and properly scaled. Okay, so I'm just going to take this one from the memo that I got here. Sure, I did have the memo here. Have I lost it? Yes, it's here. Here we go. All right, so here we've got the box and whisker plot. So this is our 5, this is the 13, and this is the, what was it, 24. I think this one's a little bit wrong. I think that should rather have been over there. I think it was drawn a little bit differently. And then our other number was, let's see, it was, what did we say that was? 38 and 55. 38, 55. Okay, so you do need to draw a scaled line if you don't get an answer book. Don't forget that. Okay, right, well done, everybody. Stats is always the nice part that gets you going and scores you marks. So make sure that you know your work very well here and that you can do this no problem. Okay, let's go on to the next one. Question 1.2. Learners in a certain class wrote a mathematics test that had a maximum mark of 10. The teacher represented the marks obtained by the learners of this class in the bar graph below. Okay, so there's our bar graph. And I'm just going to zoom out a little bit. There we go. And now we just have to answer some questions. So I'm again going to leave you here for 3 minutes and then give it a go. And we meet back at about 15:15 and we see how this stats section is panning out. Okay, right. So let's see how many learners scored 8 marks out of 10 for this test. Anyone got any ideas? So here's our 8 marks. We check the frequency and that is 5. Good stuff, Mondre. How many learners are in this class altogether? "40" says Sebabale. Mondre also says 40. So to get that number, we're going to take 2 and 5 and 9 and 1, 6, another 6, 5, and that is 3 and 1, and add all of that together. So that gives me 7 plus 9 is 16, plus 1 is 17, 12 is 29, 30, I get 58. Oh, the 2, thank you. There we go, 40. Thanks, Artis. Calculate the range of the marks scored in the test. What's the range of the marks? What is the range of the mark? So we look at the highest mark minus the lowest mark. So our highest mark obtained is 10, and our lowest mark obtained was 0. So that's 10. The range of marks is 10. Now it says in 1.2.4, if the pass mark for the test was 50%, what percentage of the learners failed the test? Okay, so here's our pass mark, 50%. So we're obviously going to look where, how many people scored below that. So let's have another look, Mondre. So if, the percentage of learners, oh yeah, you might be right. Let's work it out. So 1 plus 9 is 10, plus 2 is 12, plus 5 is 17, plus 2 is 19. 19 out of the 40. Yeah, those who failed the test, that's 19 divided by 40 times by 100, and that is 47.5. Harties, well done. Okay, so just again, we're going to add up everyone who got below 5. So that's 1 plus 9 is 10, plus 2 is 12, plus 5 is 17, plus 2 is 19. Of the total, which is 40 times by 100 to get a percentage, that gives me 47.5%. So, oops, about 47.5% of the class failed the test. So now we're going to calculate the mean mark scored in the test. How are we going to go about that? So we're basically just going to take each mark and times it by its frequency and then add it all up. Okay, so we're going to start with the 0. So that is just going to be 0 because we're timesing it by 0. But let's include it anyway so we know we accounted for it. Then there were 5 people who got 1. And then there were 2 people who got 2. And 9 people who got 9. 9 people who got 3. So that's 3 times 9. There we go. And then 1 person got 4. And no people scored 5. 6 people got 6. Plus another 6 got 7. Quite a long sum. And then 5 people got 8. So 8 times 5. And then 3 people got 9. 9 times 3. And then 1 person got 10. 10 times 1. Okay, so put that into your calculator very carefully and then pop your answer in the chat when you get it. Okay, 290, Mondre says. Anyone else? Anyone else got it worked out? I'm also getting 195. So Mondre, maybe just check again. It's easy to make a mistake here. So just work very carefully and meticulously. Don't need to rush. We are not in the exam yet. But even in the exam, you mustn't rush. You must just work carefully and consistently. So that's 195. And to actually get the mean mark, we need to take the 195 and divide it by the number of people who wrote the test. So we're going to divide the 195 by 40, and that gives me 4,88 out of 10. That's what they got for this test as an average. Okay. Well done, everyone. That's the stats. I think that's quite nice. Remember, you also have the estimated mean that you just need to go over. But yeah, otherwise we can move on to the analytical geometry. Here we go. Let's see. Okay, I'm going to give you some time to look over the question. Just going to make it a little bit smaller. Okay, and this also brings in your knowledge of quadrilaterals. Okay, so read the question and then we'll get started. As always, post your emoji face, your reading face in the chat. Are we still reading? Okay, there we go. Thought we lost you guys there for a second. Okay, so what have we got? We've got A, which is 1 and 3, B, unknown coordinates, and E with -2 and -1, and then C is the midpoint of AB. Okay, so now remember with your analytical geometry, just start noting very important things and make sure that everything that's written down is also transferred to your sketch. So it says here that AF is equal to FB, great. So those two sides are equal in length, and AF is also perpendicular to FB. Don't know where we're going to use that, but it seems important. Okay, and then we've got C, that is a midpoint. So already you can start thinking that if I have A and I have C, which is a midpoint, then B can easily be calculated. Because if I have the midpoint and I'm looking for the coordinates of another point, then I can use the midpoint formula to do that. And I suspect one of the questions is going to be that, but I don't know. Let's see. Okay, so the first question is actually, what is the length of AE? So to do the length of AE, we are going to have to do distance formula, right? So for distance formula, it's a bit like Pythagoras, and we go AE is the square root, and I'll write the formula down for you, and then I would like for you to work it out if you haven't done so already, there where you are busy. X2 minus x1 squared plus y2 minus y1 squared. Yeah, and depending on your school, I don't think you guys get these formula sheets, so you might need to memorize this formula. But right, let's work this out, everybody. Pop your answer in the chat when you're done. The length of AE. Yeah, so Harties knows he had to know his formula off by heart, no cheat sheets. Babale says square root 5. First one in with an answer here. So we got x2. Doesn't matter which one you choose as your x2. It's as long as you follow the same order with your y's. So minus 2 minus 1 and then minus 1 minus 3 squared. Guys, if you're getting a negative answer, look again. Distance can never be negative. Distance is always positive. Okay, so I get all of that worked out to be 25, and then we're going to square root that. Sorry, I'm just going to shorten it, not take it away completely. So that is 5. Good stuff. Artis. And anyone else? So Sibabale, check again. If you square root the 25, then you get just 5. Okay. Good, so we can do distance. Let's see if we can do gradients. Okay, maybe I can be quiet for this one and not give you the formula because you've been using this gradient formula since grade 9. So Let's see who can work out the gradient of AC. Change in y over change in x. That's all I'm saying. Change in y over change in x. Pop your answer in the chat when you have your gradient for AC. It's 2 marks. So 2 minutes. So we're almost out of time. I'm going to call it in about 30 seconds. Okay, there we go. Time's up. Let's see. Change in y over change in x for AC. So we go 3 minus 1 or 1 minus 3, whichever way you prefer, as long as your x's follow the same order. 1 minus 2. Here we go. And Saku says minus 2. Timologos says minus 2 as well. So let's see what's happening. 2 over minus 1 gives us minus 2. Yay, well done, everyone. Good stuff. You can do your gradient. Okay, so check that box. Distance, gradient. Let's now see if we can work with the midpoint. What is the coordinates of B? 2.1.3. The coordinates of B. Okay, so we know that C is our midpoint. C is 2 and 1. So if we have that midpoint, then we can use the midpoint formula. Midpoint. So the midpoint formula is just x1 plus x2. So that's the 2 coordinates at the ends of the line. So if C is the midpoint of AB, then we're looking at the x coordinates of A and the x coordinates of B, add them together and divide by 2, and then the same for the y coordinates. But we don't have the x and the y coordinate for B, but that's not a problem. We can substitute what we have and then make an equation. So if we take our x coordinate of our midpoint, that we've got, that's over here, that's 2. So we know what that midpoint coordinate is. We have the x coordinate at A, so we can add that to our x coordinate at B and solve for it that way. And then do exactly the same, follow the same logic. Those of you who were here when we did all of this, we did so many of these examples when we did analytical geometry, because they just love asking this question. Okay, so be ready for this one. Sometimes they ask a straightforward midpoint. Sometimes they ask this one where the midpoint's given and you have to work out the coordinates of one of the other points. So we have y here is 1. 1 is our coordinate for our midpoint. So we can say 3 plus the y coordinate at B divided by 2. Okay, and now we're just going to solve these 2 equations. So we're basically going to say 1 plus what divided by 2 is going to give me 2. Or I can just solve for it properly like a normal equation. And we do that by timesing by 2. If I times by 2 on the one side, I times by 2 on the other side as well. And then subtract. So that's That's our x coordinate at B. And then we do the same on this side. To get rid of the 2, we times by it. And because we do it on one side, we must do it on the other side as well. So that's 2 and 3 plus YB. And then we subtract. So the y coordinate at B is -1. Okay, so remember that one, watch out for it. And if you want to do more of those, you're welcome to go watch our analytical geometry lessons on the midpoint. We did many, I remember. Okay, right, let's go on. We do have about 8 minutes left. So let's see what else is there. So BE is joined to form a special quadrilateral. Okay. So we do that. Special quadrilateral. Can anyone see which quadrilateral it is? We've got these two sides that are equal. And we've got a 90-degree angle there. So which one is it? Does anyone know? Name the special quadrilateral and then give full justification for your answer. Any ideas? What do you guys think? Yes. Which quadrilateral? I mean, there's only so many. I don't think we can go through a process of elimination. I don't think it's a square. I don't think it's a parallelogram. I don't think it's a rhombus. So none of the parallelograms. So not a rectangle. So that only really leaves us with 2 other options. So what do you guys think? I'm not going to tell you. You can tell me. Mondre says it's a kite. I agree, Mondre. I think this is a kite. And why would you say it's a kite? What is your justification? You guys have to know the properties of your quadrilaterals for your paper 2, hey? So you got to know, this is not like a separate section. This is all, the quadrilaterals can come into your analytical geometry as well. 2 adjacent sides are equal. Well done, Sibabale. That's right. 2 adjacent sides are equal. Got it. Okay. Good. So let's just write this here. 3 and -1. Okay. Now, the next question asks us to calculate the area of triangle AFB. Triangle AFB. Does anyone have any ideas how we're going to do that? AFB. If we are calculating the area of a triangle, what do we need? What is the formula for area of a triangle? What do we need? So start there, and then you just start filling in the blanks. So area of a triangle, yes, it's now here in analytical geometry, but that's not surprising because we work with shapes on the Cartesian plane when we do analytical geometry. So what do we need? What is the formula for the area of triangle, of any triangle? Half base times height. Well done. So we need the base and we need the height. Okay, so the base and the height. Now it really helps that this triangle is a 90-degree triangle, I think. So I'm wondering, any ideas how we're going to do it? What have we got that we can calculate? If it's half base times height, which measurements would that be? The base and the height go together, right? So we are looking at where the 90-degree angle is being formed. So the base is BF. You can make the base BF, and the height is going to be AF. Okay, what's the problem here? Height is AF. Well done, Sino. So what is the difficulty what is the roadblock we are facing here? It would be very easy to just go calculate BF, calculate AF using distance formula, but what is our roadblock? We don't have F's coordinates. Well done. Now we need to find a way around the roadblock. Okay, and this is just the way, maths is like one big puzzle that you are solving. So you've hit a roadblock. Okay, what else can I do? And what else can we do? What else can we do? Which distance can we work out? And also think right triangle. What comes into play when we have a right triangle? You can do AB's distance. Nice, you know. And then, how's that going to help? What's also important, what we know about BF and AF is that they are the same. They're the same distance. So that's helpful. So that helps us around the roadblock as well. And if we get AB, what other tool do we have that we can use to work out the distance of sides? Not the midpoint, but if we are talking distances, what other tool have we got in our pocket when we are working with a 90-degree triangle? Nice, Timologo, Pythagoras. Well done. Now, how are all those pieces going to come together? We can work out the length of AB using the distance formula. And then we can use Pythagoras to find what AF and FB are, because they are the same distance. And once we've done that, once we have those distances, we can actually just multiply them together, times by a half, and get the area of a triangle. Okay, I'm going to put the memo up for you because we are out of time. But what's important is that I want you to, when you are faced with a problem, just think through it. Just think through the roadblocks and think through what it is that you can do, because you have all the tools at your disposal. You just need to use them. Okay, so there we go. We work out the length of AB first, and then we find, what is this? This is AC, so maybe this is a little bit different to what they okay, so they do it slightly differently, but they do use Pythagoras. So they work out what AC is. Oh, and then they actually use some trig as well. You can do that. Pythagoras would have worked just as nice. Okay. Right, guys, that is it for this evening. And our last lesson for the year will be on Thursday. On Thursday, we're going to tackle the trigonometry and the trigonometric graphs. And if there's time, we'll do a little bit of Euclidean geometry.